Okay, so we're reviewing for the algebraic manipulation test. It's not happening tomorrow, but it's happening the next day. So this lesson goes along with algebraic manipulation number 3. It's the review for it. I want to go back in time. Do you remember when you were asked how to add, actually that's a little too thin, I'll write with a thicker marker here, this. Do you remember those? Okay, so we had to clear the denominators. Do you remember that? All right, if you really remember that, go ahead, clear the denominators, and just multiply it all out and see what you get. You don't have to solve it. I just want you to get it down to an equation that doesn't have denominators anymore. For those that are kind of lost here, you're going to be multiplying by both denominators, x and x plus 5 on every part. All right, so here's how it would go. That x would cancel that x, and then I got x plus 5 left. This x plus 5 would cancel this x plus 5, and then I'd have 2x left. And this one would become 5x times x, and then 5x times 5. So 5x squared plus 25x. Now do you get when you put it all together? I'm going to make this x go with this 2x, that'll make 3x, and then I'll put over to the other side, that'll subtract 3x. Now I got 5 equals 5x squared, and I'm subtracting 3x from both sides. So then that's going to make this 22x. And then I have to get the 5 over to the other side and make it minus 5. There, look at that. What did I just make? Starts with a Q. That's a quadratic, and then you know how to either factor it to solve it or quadratic formula to solve it. Either one works. From there, I hopefully don't need to remind you. You were doing this last year. The factoring would be pretty tough on this one, so don't worry about this one too much. We'd have problems that weren't too bad from here. Okay? Just have to use the quadratic formula if you can't factor it. Don't spend tons of time going, oh, how do I factor it? I can't remember what the numbers are to make this factor. Just go to the quadratic formula then if the numbers are that nasty. All right, next kind of problem. Do you remember the mixture formula? All right, so once I teach you this one, though, it's going to be an easy point in the test. As long as you know this formula, you got to know this amount 1 times percent 1 plus amount 2 percent 2 equals total amount and tot percent. I'm going to give you a problem, see if you can handle it. Stick the numbers into this formula. Say that you, for instance, have a bottle which is 1/3. Okay, no, so let's say how much of this bottle is. This is probably about a 20-ounce bottle. So let's say that there's about 6 ounces of pop in here, but there's also 6 ounces of water in here. So what percent is this pop? Think of the pop as like acid. So what percent acid is it? This bottle, if this bottle has 6 ounces of pop and 6 ounces of water mixed, then what percent pop is it? Oh, come on. If it's half pop and half water, what percent is it? 50%. Okay, so it's 50% pop, and how much of that is there? How many ounces is there? 12 ounces of 50% pop. I'm trying to make you be able to understand that in the real world instead of just saying 12 ounces of 50% pop. But I'll just say 12 ounces of 50% pop because apparently that was too difficult. All right, and you're going to add to that pure pop. What is that? What percent pop is that? 100%. How much? I don't know. You're going to add pure pop. I don't know how much. Some of you are not writing yet. That's a bad sign. Grab a pencil, grab some paper. Don't make me come and get you. You can always borrow them from me if you have to. They're on my desk. All right. So I'm going to go with pure pop, which is 100% pop, which is instead of putting a 100, I'm going to put a 1.0 because we're changing it to decimals. And then how much? I don't know. And then my total amount, I got to tell you what percent I want. I want this to just change from 50% pop. I want it to change into 55% pop. Did I tell you how much to add? No. But I told you the total percent. I wanted it to be 55% pop when you're done. That's a 0.55. That's the hardest part right there to do. What do you do? What is the total? Not minus x. We're adding them together. 12 plus x. There you go. And that, from there, you should be able to do the algebra on. The total amount is not 0.5. The total percent was 0.55. This is 55% pop at the end. See? Look at total percent. 55%. It's a good question. I believe that the calculator will be allowed for this problem, but I don't know, so I'll tell you for sure tomorrow, okay? If it's not allowed, you'd have nicer numbers than this. Okay, so 0.5 times 12 is 6, plus x times 1 is x. So you see how that cleans up to be so easy after that? Equals, and now this part's not so nice. Now I probably want a calculator. 12 times 0.55. Has somebody already done that? 6.6, thank you. And then plus 0.55x. Now I got to get my x's, I got them on both sides, so I got to get rid of my smaller one. So I take away 0.55x from both sides. And then 1x minus 0.55x is 0.45x. The 6 is still here, equals 6.6. And now I'm going to subtract the 6 from both sides. 0.45x equals 0.6. And I'm almost done. X equals 0.6 over 0.45. Thank you. What is it? 1.3 repeated. Okay. What does that mean? What did I just figure out? I figured out x. What was x? That's how much what? How much pop I was supposed to add. So I'm supposed to add 1.3 ounces of pop. And that makes my mixture 55% pop instead of 50% pop. All right, I'm going to give you one more like that. See if you can handle it from start to finish without me. You need that formula. If you haven't got it memorized yet, memorize it. All right, this one I'll make a little bit simpler. What happens when you mix 5 ounces of 90% acid with 8 ounces of 4% acid? I'll start it over again. What happens when you mix 5 ounces of 90% acid with 8 ounces of 4% acid? This really is a powerful formula. It can be used in so many different ways. It could be used, for instance, to mix what if you're having stocks and bonds in your portfolio and you think your stocks are going to get 9% return and your bonds are going to get 5% return, and you weight it like, ooh, I put most of my money in stocks, so I made a lot of money this year or whatever. Well, if from here you wanted to change it into a grade question in Minnetonka, or at least in this class, we have 85% of our grade based on tests and 15% of our grade based on other stuff like homework and quizzes, like homework quizzes in class, etc. The point is that you can get your weighted grade from this. You can instead do the final grades, your final semester, your semester final, sorry, that's happening in a few weeks. That's worth what percent of your grade? 15. In this class it's 15. 15% of your grade, and 85% of your grade is all the other quarter stuff, all the other grades you've had up to this point. Okay, so it's an 85-15 thing. So you could figure out for yourself by using the same formula. What grade do I need on the final to keep my A? Or if I want to raise my grade with the final, which by the way is really tough, but if you wanted to raise your grade with the final, Well, how high of a grade would I have to raise my grade? So you can use this formula for that. All right, the one I just asked you about, that was 5 ounces of 90% plus 8 ounces of, what was that other percent? 4%? Thank you. What would I get? Well, my total is easy in this case. It's just the 8 and the 5. So I get 13 ounces. I know that for sure. That was pretty easy. Of what? Well, I can't just solve, I don't know the total percent, do I? Nope. So I don't know what the total percent is. That's the whole point of the problem. So what do I put for that? X. And then you solve for X. So 9 times 5 is 45. So this would be, let me think, 4.5, right? Plus 8 times 4 is 32. So I got to give a decimal in there. How about 0.32? Does that seem right? Okay. Equals 13x. And then I'm going to add these together. 4.82 equals 13x. And so I'm going to take 4.82 divided by 13. Somebody must have already done that. What'd you get? A little louder? That seems reasonable. And what percent is that? 37%. And now does that make sense from our problem? We had some 90% and some 4%, but I had more 4%. Get how it's a weighted average? There's more of this. So it's not like you just average the 90 and the 4. So it's a little weaker than it would have been if it had been an equal split. But because there's a lot of the weak acid. So it makes sense to me that it's about 37%. So raise your hand if you had that one right. Okay, good. Can't afford to spend too much time on any one kind of problem, but that's another type of problem you should know how to do. Next kind, the kind we've been working on for a long time. Let's say that we had that. What are you going to make before you're done? That's a big, takes you a long time, but you need to do it. A number line. Big, long number line that's got a whole bunch of points on it. You get into test intervals and all that. Let's not do all of it, because this alone would probably take you 8-10 minutes to do. So just how would you do it? Well, how about this? Would you agree that 3 is important? Okay, so 3 goes on my number line. What is it? Is it a 0 or an undefined? It's something that makes the top 0. That's a 0. Okay, how about the -4? That's important. So what does that do to it? Undefined. That's a U. All right, and how about the 5? That's also a U because it would make the bottom 0, so that's an undefined spot. Now I would check and see where it's positive and where it's negative. And I'm going to check just one of my little zones here. My favorite thing is 0. It's in here, and I'm going to check 0. If I put in a 0 and check and see what happens. This, by the way, is the part everybody screws up. They all get these numbers right on the number line, and then they put their pluses and minuses in the wrong spot. So be careful. I'm going to test 0. It's negative here, but then it gets squared. So what's the top? Positive. So it's positive. I'm going to do show my work down here. Positive over, and then if I put in a 0 here, that's positive. I put in a 0 here, that's negative. So it's positive, negative. If it's positive or positive, negative, what's the total? Negative. It's negative in this little zone right here. So is that little zone going to work then? Well, if it's negative, is that bigger than 0? No, so it does not work in that zone. Get the idea? And you check all the rest of your intervals. And endpoints are really important. Let's find a place where it actually works. So let's try 4 here. I put in a 4 here, and a 4 here, and a 4 here. It's going to be positive over, oh, that's negative again. That one didn't work. Okay, I'm going to try 6. Put in a 6 here, and a 6 here, and a 6 here. There we go. Positive over positive, positive. So the whole thing is positive. Is that bigger than 0? Yes. And so therefore it works in this little zone. And therefore part of my answer at least would be between 5 and infinity. And does 5 work? No, U's never work because they are undefined. So it would be from 5 to infinity like this. And I'm not sure if there's another zone. I suppose I could just test it. There's only one more spot. Let's test -5. Put in a -5 here. It's still going to be positive on top because it's squared. It's always positive on top. So it's positive over. If I put in a -5 here and a -5 here, it's going to be negative, negative. Positive or negative, negative means positive. It works there too. So since it's positive, it's bigger than 0. So it works in this little zone. So final answer, it would be from negative infinity to -4 and union that. There we go. Whew. What? Wait a minute. There's one more thing. I never even really checked this spot. It's important to check it. That 3 itself, it's a 0. In this problem, would that work? No, because it says greater than 0, and 0 is not greater than 0. But if the problem had had an or equal to 0 right there, then that would have also worked, and I would have needed to squeeze in an extra thing like union 3, union, get what I'm saying? Because it's really common for people to like notice that this whole zone works and this whole zone works, but they forget about an individual point sometimes working. And if I had changed the problem to say or equal to, then 0 would work and the 3 would have to be included. So you have a little bracket around the 3 like that. That's about as hard as they would get, yes?
That one, on the last side, it said like 3, 3, or did you just write bracket 3?
I just put the bracket 3. There is multiple ways to write that, but the easiest way is just put brackets around a 3. All right, let's move on to a different kind of problem. All right. I already covered the acid problems. What else do we have here? Ah, yes, some classic word problems. All right, yes, there are some word problems on here. So let's do one. Draw yourself a rectangle. If I tell you that the area is 400 and the perimeter is 40. There's a length and there's a width, right? Area is 400. Perimeter, that means like all the sides added up together, is 40. Then pick one of your sides to be x. Doesn't matter which one. I'm going to call this one x. What's the other side? It's not necessarily 2. Right? 2x? Do you know it's twice as long? Okay. 40 minus x? No. Okay. So if you know the total of this thing, you could have done it 2 different ways. Do you agree you could have done it with the 400? Because the x times something would have to equal 400. So then you could have said, what? Nope. Okay, I'm going to go to a different one for just a second. I'm going to give you a simpler one. Let's say that this has an area of 80, and this side is x. What's the other side? And it's not 80 minus x. Stop that. This is an area. How about if I go with the pure form of the formula? Remember that thing? Would you agree it's A equals length times width? You agree with that? Okay, what's the area? 80. What's the length? Now we usually call this the width. The length is L, and then what's the width? X. And so what's this side then? It's L, right? 80 divided by X. Okay, I don't want that to be a mystery how that's 80 divided by X. I know there's a lot of options. I heard 80 minus X, I heard 80 times X, and I did hear some people saying 80 over X or 80 divided by X. All right, so back to this problem. What could that side be? 400 over X. Or, what's another way to do it with the perimeter I gave you? 40 minus 2X. And how are you getting that? Let me show you. People, you should be doing this. Perimeter equals 2 lengths plus 2 widths. And my lengths, I don't know. but my widths are x's, and then my perimeter is 40. That's how you can get your L to be alone. And then I'd have, let's see, subtract 2x, 40 minus 2x equals 2L. And oh, look at that. It's not 40 divided by 2x, is it? I'm almost done here, but some of you just assumed that was 40 minus 2x. Divide by 2 on both sides. And L equals, I'm going to divide this by 2. 40 divided by 2 is 20. Minus 2x divided by 2 is x. 20 minus x. Is 40 minus 2x and 20 minus x the same thing? No. This one wasn't divided by 2 like it should have been. So final answer, this side could be 20 minus x. Or it could be 400 over x. Either way would work. Do you get then that that means that 400 over x is equal to 20 minus x? Does that seem like an equation you could solve then? It is. Okay, why was it 20 minus x? I better do another one like that. How about this? Perimeter on this guy is 90. If this side is x, what's that side? Don't say it out loud. Figure it out for yourself. I would start by writing area equals 2 lengths plus 2 widths. That's supposed to be a rectangle. The perimeter is 90, yes. The perimeter is 90. The one side's x. What's the other side? Don't say it out loud. Just write it down on your paper. I had like 6 different answers last time, and they were all wrong. It's okay. I would have probably got it wrong to my first guess. So you go perimeter equals 2 lengths plus 2 widths. Perimeter, I told you, 90. 2 lengths, I don't know the length. I'm leaving it as L. The widths, I know those. Those are x's. And you solve for x. 90 minus 2L is not the answer. 90 minus 2x is not the answer either. Because L is not alone yet. You get how I have to divide by 2? So, final answer. Divide that by 2. And you could either write 90 minus 2x over 2, or actually divide it. What's 90 divided by 2? 45 minus x. Who had that right? Raise your hand if you did. Okay, good. If you didn't, go back and watch the video over again, see if you can follow it. Okay. I'm going to give you one more like that. The perimeter of the rectangle is 200. And I want the area to be 40. The perimeter is 200. That means your other side has to be really, really small. The area, the perimeter is 200 and the area is 40. Isn't that what I told you? Make sure. Okay. Perimeter is 200, area is 40. So it's long and skinny. But you won't figure out what the numbers are until you do the math on it, so give it a shot. I can figure it out. How long are the sides? What are the dimensions? Pick one of them to be x, by the way. Perimeter was 200 and area was 40. Have I got that right? Okay. There's 2 different things you could say for that other side. You could figure out one of them in terms of x, one of them in terms of the perimeter thing. And you could do it the other way with the area. All right, so this side Would you agree the easiest way is probably 40 over x? Like that? Okay. And then the perimeter way, I'm going to do that out on paper. Perimeter is 2 lengths plus 2 widths. Perimeter is 200 equals 2 lengths, and I don't know the length, I better leave it as L, plus 2 widths, which is 2 x's. Okay, but there's one more thing. Right here, if you wanted to, you could skip a bunch of work and just say, I know what L is. It's 40 over x. You get that? So right here, I could just say 200 equals 2 times the length is 40 over x plus 2x. Does that look like an equation you could solve? Yep. It may not be very fun, but you could solve it. What if you had a graphing calculator? What could you do? Graph both sides and see where they cross. Remember that? All right. Why don't you grab a graphing calculator and give that a shot? All right. I'm going to put in 200. And I know, of course, that's not going to show up on my graph because my graph only goes to 10. But I'll zoom out and fix that in a minute. And then I'm going to have 2 times parentheses 40 over x, 40 divided by x, end parentheses. And then I go plus 2x, plus 2x. And now when I graph it again, I don't expect to see the answer yet because I'm only going out to 10 in both directions. So I'm going to actually just think about it and go to window and say my x's, or my my y's, like y equals 200 is one of my things on my graph. My y's have to go as far as 200, so I'm going to make it go as far as like 300. So my y max, I'm going to go to 300. My x's, I don't know how far to go, but it's probably safer to go big. Go big or go home. So let's go 300 on that too and see what happens. I hit graph and see if I can see where they cross. Look at that, I can see where they cross. Now you remember how to get the rest? Second calc, intersect, enter, 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 boom, boom, boom. There it is. X is 99.59. Now I wouldn't use y equals 200 because I already knew that. That wouldn't be nothing new there, right? I needed to figure out x. X is 99.59, so what did I just figure out? This side here has to be 99.59. That means this side right here has to be the same thing. That doesn't leave much for my other side, right? So you just take 40 divided by 99.59, and it'll tell you what that is. It's a really small number. What does it come out to be, like 0.3 something or? 0.4. 0.4? Rounds to 0.4? What's 40 divided by 99.41? All right, so this side's 0.41. In the real world, then what does it look like? It looks like this. It makes sense. It had a huge perimeter and a tiny area. It had to be long and skinny. Wouldn't have much area that way. Okay, so it was 99 point something this way and 0.41 that way. All right. I think that's enough review for today. Remember, we got tomorrow also. I'll help you in a moment. And here comes your review worksheet. It's enough for the video for today.